Hey, PCalc. So, that lesson about 3.1, slopes of tangent lines, slopes of secant lines, average rate of change, instantaneous rate of change. Let's just take a deep breath and see if we can kind of work our way through just a couple of the exercises from the textbook. 3.1. So the first thing I'm going to do is just really hone in number 1b. Not even going to touch 1a with the a's and whatnot. You're supposed to find the equation of the line tangent to f at the point P. So, what do equations of lines look like? You need M, you need B. The bulk of our work is going to be solving for M, because M tan is the huge formula that we were talking about today. So in step 1, to find our slope, we use the formula, the limit as h approaches 0 of f of x plus h minus f of x all over h. And since we're doing it at x equals 2, you can just plug right in for the x here and the x here. You can just say, plug a 2 in right away. Now, this is the point at which I have to bring back in the, well, first of all, let me give context to this problem. What even is f of x? Because it says tangent to f, but I didn't give you guys one. Keep in mind that f of x is equal to 5x squared minus 4x. So I'm plugging 2 plus h into any spot where I see an x in that expression here. So it's like you've got 5x squared minus 4x. The red highlighted stuff is basically just me saying 2 plus h is going in there. And I can do the same thing with f of 2. So I'm subtracting 5 times 2 squared minus 4 times 2. All divided by h. So now we would probably go off to the side and do a little scratch work with this. Let's make this our scratch work paper. Two plus h squared is going to be 4 plus double 2h plus h squared. That's the shortcut for squaring a binomial. Here is just going to be, oh shoot, I'm sorry, that should be 2 plus h. There. That should be minus now 8 minus 4h. And then we could just compute what's going on inside here. This is 4 times 5, 20, minus 8. 20 minus 8, 12. I'm just going to combine these two and call it minus 20 right away. Minus 20 is 0. 20h minus 4h is 16h. All right, so everything on the top part right there should be 16h plus 5h squared. So I'm going to put that below. We could factor an h out of the top and divide it out with the bottom. So the two h's up top cancel with the h on the bottom. Okay, plug 0 in for h. We found our slope. So it took a while, but we found the rise over run of the line tangent to that curve at x equals 2. Step 2. Step 2. Find b. So you got y equals mx plus b. I know my x coordinate is 2 because that's what they're giving to us. You plug in f of 2. We actually did that already. Remember when we plugged in f of 2 right here? It turned out to be negative 12 or positive 12. Let's try that again. 2 squared is 4 times 5 is 20 minus 8, positive 12. So y equals 12 is the same as f of 2. And then, of course, we know our m is 16. We're going to plug those three items in for this equation. So y equals m times x plus b, and then get b by itself. And then step 3 is just to make sure you write the equation of that tangent line. Y equals 16x minus 20. Okay. So there was a lot going on there. We had to actually use the formula for the tangent line, but a lot of it was just us plugging in, using our algebra skills, and once we found m, which was a single number, we plugged it back into y equals mx plus b, and we solved it like a champ. Okay, let's try another one. Let's do number 9. Number 9, and I'm just going to do part B. So they give us this function, y is the same as f of x, and they say 2 1/2 is the point, which we're trying to write the equation of the tangent line to. Sorry, you couldn't see any of that. That's frustrating, I think. There we go. So, we need this. Come on now. Step 1. The slope of the tangent line is still that limit. The limit as h approaches 0 of f of x plus h minus f of x all over h. And we're doing it at x equals 2. So I can instantly put the 2 in right here and the 2 in right there. In fact, I already know what f of 2 is. It's a half. So that's going to be a half for sure. Can I just do that right now? Why not? So then now you're doing 2 plus h in place of every single x value here. So it's going to be the limit as h approaches 0 of 1 divided by 2 plus h minus a half, all divided by h. So now this would probably be an appropriate time to go off to the side and do some scratch work to get this to simplify down to one fraction, one numerator, one denominator, not this messiness. Come on over. You know, the first thing I'm going to do is, instead of writing it divided by h like this, I'm going to write it as divided by h like this. So what I need are common denominators here. This one needs to be multiplied by 2. And this one needs to be multiplied by 2 plus h. So sorry, that's kind of messy, but you're going to have 2 minus, distribute a negative 1, distribute a negative 1. This is still inside the parentheses. And then you're going to have 2 times 2 plus h on the bottom. Now divided by h is the same as times 1 over h. The 2 minus 2 cancels, and you're left with negative 1h over 2 times 2 plus h times 1 over h. The h's cancel, and that was the domain issue that we needed to cancel out in order to plug in that h approaches 0. Remember, limits were just a game of saying, I got a domain issue, I need to get rid of that domain issue. We just did it. So this is the limit as h approaches 0 of negative 1 times 1 all over 2 times 2 plus h. And then actually applying the limit to that means plug 0 in. So 0 goes in for the h. It's 2 times 2 on the bottom. Our slope is negative 1/4. The slope of the tangent line is negative 1/4. All right, step 2. I'm going to choose x equals 2, y equals a half, and negative 1/2 is my m. Sorry, negative 1/4. Half. Negative 1/4 times 2 is negative 1/2. Add 1/2 to both sides. 2 halves make a whole. All right. We have solved the two important parts, the slope and the b value. So you just bring it all together at the end. Y equals negative 1/4 x plus 1. So that was part B. Part C says sketch that curve, 1 over x, and sketch the line tangent to it at that specific point. So I'm going to do that right now. I'll just do kind of a rough sketch of it. So 1 over x, what does that look like? Well, it's got an asymptote on the y-axis. Because if I divide by 0, that's an error. X equals 0 is the y-axis. And it looks like if we're really just focusing on everything right of the y-axis, you're going to have positive values. So at 1, it equals 1. At a half, it equals 1 divided by a half. It equals 2. At 2, it's a half. So you're talking about this curve here. It never goes below the x-axis. It never goes left of the y-axis unless we would draw its corresponding curve in quadrant 3 down here. All right, what does negative 1/4 x plus 1 look like as a line? Well, it's got a starting point of 1, and it goes down 1, right 1, 2, 3, 4. So again, it's a rough sketch, but what they're trying to get you to do is just visualize like, hey, there's a real curve here, there's a real line, and that's the spot that we're actually talking about when we compute all this good stuff, okay? I think I'm going to stop the video here. I still want to show you guys number 19, but let's do it in a different video.